Hi there, in this video we're going to learn how to factor linear expressions. To factor a number means to write it as a product of its factors. The GCF, the greatest common factor of two monomials, is the greatest monomial that is a factor of both. Find the GCF of the following monomials, 4x and 2x. So the purpose of finding the GCF, that just means to just find the greatest common factor. So the greatest number, or the greatest factor, I should say, that goes into both 4x and 12x. Here I show you how to make a tree diagram. I'm going to start with a 4x, and how can 4x be broken down? Well, you can break it down as 2 times 2 times x, right? Now how can 12x be broken down? You can break it down to 6 times 2 times x. Now, is there anything else that can be broken down here? Well, yeah, the 6 can, right? The 6 can be broken down to 3 times 2. So on this side, I have 4x to equal 2 times 2 times x. And on this side, I have 12x to equal 3 times 2 times x. 3 times 2 times 2 times x, I should have said, because there's a 2 here. Let me make that so that it's more spaced out a little bit. Okay. From here, you just pull out your greatest, or from here, you just pull out your common factors. So one common factor is a 2, right? I have a 2 here. I have a 2 here. And another common factor is I have a 2 here, and I have a 2 here. So notice I pulled out 2 2's, which is why 2 2's are down here. And I'm also going to pull out an x. Here's an x. Here's an x. Now it's 2 times 2 times x. Once I multiply this, this becomes my GCF. 2 times 2 is 4, times x is 4x. So the greatest common factor that goes into both of these is 4x. This example says, find the GCF for the following monomials, 18a and 20ab. 18a can be broken down to 9 times 2 times a. This 9 can be broken down further to 3 times 3. So in all, 18a can be broken down to 3 times 3 times 2 times a. 3 times 3 is 9, times 2 is 18, times a gets you 18a. Here we have 20ab. Well, 20 can be broken down to 10 times 2 times a times b. 10 can be broken down now to 5 times 2. So your common, or your, I should say, your factors are 5, 2, 2, a, and b. 5, 2, 2, a, b. Okay, so now you're comparing these two. Now you need to pull out your common factors. So I'm going to pull out a 2, right, because I see that here and I see that here. And I'm also going to pull out an a because I see that here and I see that here. So my GCF here would be 2a. Factor form just means that you turn an algebraic expression into a product of its factors. It's kind of like using the distributive property backwards. So here we have 8x plus 4. Some of you guys might right away be able to pull out your greatest common factor, which is 4. That's the biggest number that goes into both of these, the biggest factor, I should say, that goes into both of these. If not, I have the tree here of how it can be broken down. But we're going to work on this side mostly. So the GCF is 4, right? 4 goes into both of these. So this is how I'm going to set up my factored form of this expression. So 4 times what plus what? So that's why I have the 2 blanks. So in this first blank, you need to think 4 times what number is going to give me 8x? Or you can think 8x divided by 4 gets you what number? Okay? I like personally thinking of it as 4 times what gets me 8x, because that makes me start thinking about the distributive property a little bit. So 4 times what gets me 8x? Well, 4 times 2x gets me 8x, right? So 2x is going to get put right here. In this blank, we're going to look at 4 times what gets me 4? Well, 4 times 1 gets me 4. So my factored form is this right here. 4 parentheses 2x plus 1. This is a factor form of this. If you distribute this 4 across, you're going to get 8x plus 4. All right, here it says factor the expression. We have 3x plus 9. Your GCF, in case you can't tell, is 3. 3 goes into both of these, and 3 is the greatest number that goes into both of these. 3x can be broken down to 3 times x. 9 can be broken down to 3 times 3. You can pull out a 3 from both of these. Okay, so once you pull out a 3, you need to think. 3 times what gets me 3x? Well, 3 times x gets me 3x, right? Here you need to think. 3 times what number gets me 9? 3 times 3 gets me 9. So your answer is 3 parentheses x plus 3. Now we have another example. It says factor 2x plus 7. Well, let's pull out the greatest common factor first. 12x can be broken down to 6 times 2 times x. 7, well, can 7 actually be broken down besides 7 times 1? No, can't be broken down anymore. So guess what? This example cannot be factored. So then you just write cannot be factored. And for our last example, we have factor 4x plus 28. 4x can be broken down to 2 times x. 28 can be broken down to 2 times 14, and then 2 times 7. Okay, so 4x is equal to 2 times x. 28 is equal to 2 times 7. So your GCF here, okay, well, what can you pull out from both of these? You can pull out a 2, right? I see a 2 here, and I can pull out another 2. I see a 2 again. So, and I pulled out 2 2's now. So my GCF is 2 times 2, which gets me 4. I can pull out a 4 from both of these numbers. So, here I set it up. 4 times what gets me 4x? 4 times x gets me 4x. 4 times what gets me 28? 4 times 7 gets me 28. So this would be my answer in factored form. Some concluding thoughts. To factor means to write as a number, to write a number as a product of its factors. Factored form is when the expression is factored. To put an expression in factored form, first you need to find the GCF. Then you need to pull out the GCF. And then you need to use the distributive property and kind of work backwards. Meaning, think about the GCF times what number is going to get me my 2 factors here. All right, I hope you learned how to factor linear expressions. Thank you for watching.